This is Josh White with JW Math Tutoring. In today's video, I'm going to cover 10 new problems from the May 2026 Digital SAT Math Test. So let's go ahead and get right to it.
But life is a dream that calculus could never predict.
Just before I go ahead and get started on these May 2026 Digital SAT Math problem set worksheet number 1, just want to mention a couple things that I talk about at the start of each of these videos. First, of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, there'll be a link in both the description of the video and the pinned comment to a PDF file which has all of these problems in it that you can download and complete. Third, these are all self-reported problems, so you might see minor differences or major differences compared to if you had one of these problems on your official exam. So just be aware of that. I've tried to reconstruct them as best I could, but in some cases they might be different than the actual problem you saw on the test. So for some of them that might mean the problem is done as a free response rather than a multiple choice. Or there might be, again, other things that are different about the problem than what you had on the test. But I've tried to make it, make the problems as realistic as possible. Another thing, please do watch the videos for part 2, which is going to have 10 more new problems, once that is posted. And then also part 3, which will highlight 20, basically what I'm calling repeat problems. So these are problems that have been featured usually at least once, but oftentimes more than once on previous official exams. And so you can find the full solutions to them in other previous videos. There might be a couple problems here that have been featured, once before, but I still like to highlight them. Some of the the important ones are the common ones on occasion. I think that should be it. So let's go ahead and get started with this May 2026 Digital SAT Math official test, problem set number 1. All right, so the first one is a very common problem that I saw posted about a lot everywhere. I do want to mention there is a problem which it's nearly identical or perhaps completely identical to this. It was the very last problem in Module 2 of Practice Test 2 in Blue Book. However, they retired Practice Test 2 along with Practice Test 1 and 3 back in February of 2025 when they introduced Practice Tests 7 through 10. So they took away 1 through 3 at that time. And so this problem, essentially, you could say, disappeared from everyone's radar because you wouldn't have had it unless you still had kept a copy of the, the old Blue Book practice test. Anyways, so this problem has been out there, is my point. People have seen this before. So first I'm going to show you how to do it by hand, then we'll talk about a little bit how you could do it in Desmos. So basically, the first thing you want to check on is A. All right, so if you notice here, essentially f of negative 1 equals f of 7. That means if you graph this thing out, okay, over here at negative 1, say there's some y value. And then over here at 7, there's another y value, and they're the same. Okay, so that means that the vertex is going to be directly in the middle between these. In other words, h is going to be the average of negative 1 plus 7. So that's just 6 divided by 2, which is 3. All right, so that means, let me just check on my notes here. Yep, h is equal to 3. However, h is also equal to negative b over 2a. So you can plug in 3 for h. You can plug in the 5 for b. And then if you go ahead and solve this, just multiply by 2a on both sides, you get 6a equals negative 5. I don't want to divide by negative 5. I want to divide by 6 because I want to solve for a. So in this specific example, a must equal negative 5, 6. That is fixed, basically. So that means that 1 cannot be true. It's not that it must be true, it can never be true, you know, um, because a in this case has to be a negative number. So that means anything with 1 is out, so it's either 2 is true or 2 is not true. So personally, what I would do in this case, rather than doing out all the algebra, which you can technically do, is I would go to Desmos, and I would basically now put in the function. Just scroll up a little bit here so I can get it on the screen. Okay, so we know a is negative 5 over 6, 5x plus c. Okay, now I'm going to add a slider for c. Now it says here we're testing if it must be less than 0. So let's just start with c equals 1. All right, what are we looking to be true? Okay, we're looking for k to be less than 0. So, is this true? No, it is not true. Okay, what about if I expand this up here? Okay, now if I go down here, so, okay, basically it looks like right around negative 7.5, negative 7.6 somewhere, that's where k, the y-coordinate of the vertex, yep, there it is equal to 0. So it looks like c has to be less than or smaller than negative 7.5. So, therefore, c does have to be less than 0. This is correct. And therefore the answer, this is true, not this is correct. This is true, that c is less than 0, because technically it has to be less than negative 7.5. Therefore, the correct answer is B. Now, I actually did out all the work to prove this. I'm not going to go through all of it here. I'll just basically skip some steps and show you. But if you take negative 5, 6x squared plus 5x plus c, and you go through and you complete the square on this, you end up with something that looks like this. All right, I gotta check my notes here. It's minus negative. It's minus negative 45 over 6. And then, in other words, when you put this into vertex form, hold on, just make sure that's that's the c, that's the constant. Okay, you get c plus 45 over 6. All right, this has to be, this right here, this is k. This is your y-coordinate of your vertex. This has to be less than 0. So in other words, c plus 45 over 6 is less than 0. C must be less than 45 over 6, but this, you can just divide each thing by 3 and you get 15 over 2. Sorry, negative. Need to subtract it over negative right here. So this is how you prove that c must be less than negative 15 over 2, which is just negative 7.5. Okay, it's much quicker and easier just to find that in Desmos rather than like doing the actual completing the square and doing it by hand. But I just wanted to point that out and show it to you. Now I will show you how you could do the first part in Desmos as well, and then I will talk about a slight modification to this problem. So if we just type in the function like this, what I would do is I would first do this, and I would see what it gives me, okay? And notice it's giving me an a value of negative 0.8333 repeating. That's because that's what a has to be. A has to be fixed. So the point is, when you're looking at this problem, which of the following must be true? Okay, if we come up with at least one example where a is not greater than 0, which is what it's asking if it must be true, then that means this is out. This, must not always be true. I found at least one example where it isn't. And now what you would do is basically what I did in step 2, or what I did, sorry, in the initial method of step 2 of the initial solution method, where I just set the slider for C and I just have to move it until I get a negative K value right here. Okay, and again, so this is just basically repeating what I already did for the first, from the first solution method, essentially, where I wrote the first part out by hand. Okay, so that's how you could do essentially the whole thing in Desmos. Now, I want to mention or show you one thing, basically, that the answer here would be different if one thing about this problem was changed. Okay, let's say you had the exact same problem, except basically the h value was negative. The way I'm going to do that is I'm going to change the 2 points here that are equal. I'm going to now make it, say, f of negative 9 and f of positive 3. So when you add those together now, you get negative 6 over 2, which is negative 3, not positive 3. So if I go back to Desmos just to demonstrate this, notice what happens now. Okay, basically, and hold on, let's get rid of this too. Notice, must A be greater than 0? Okay, the answer is yes. Here, A is positive. It's basically now, it's just the opposite of what it was before. It's positive 5 over 6 instead of negative. So number 1 would be true. Now, if you go to check on C, notice that here we have C equal to 0, which is not less than 0, but the K value, the y coordinate of the vertex, is already negative, meaning that it already meets the conditions of the problem. Therefore, if you had the points set up such that the h value, i.e. the x coordinate of the vertex, is negative, like in this example, then the correct answer would actually be letter A. This is true. This must not be true. Therefore, it would be A instead of B. So just be aware of that. I've seen different versions. People list different versions out, for the test. So you could have a different answer based on what version you have. Okay. With all that being said, that took a while to get through. Let's look at the next question. So this question is just really a super basic, simple formula. We're just solving this formula for R1. So if you want to do this by hand, you could just multiply on both sides by the common denominator, which is just 18 R1 R2. And then you're going to get R1 R2 equals, well, the R1s cancel, 18 R2 plus 18 R1. And then you subtract this over. R1 R2 minus 18 R1 equals 18 R2. Factor out an R1, R2 minus 18, and then divide by that. R2 minus 18, R2 minus 18. So I get 18 R2 over R2 minus 18. It's letter B. Okay, if you wanted to do it by hand. Now, if you want to do it in Desmos, all we have to do is type the formula. Notice it automatically picks values for R1 and R2. Now it makes them the same. That should be fine. We'll see what happens with the answer choices just when we check them. So now we're looking for whichever one of the answer choices equals 36. Okay, so it's obviously not A. B matches, should be the correct answer. C does not match. Slide this up. And we can see D does not match. So B is clearly the only one that gives the same value as R1. Therefore, you can solve this entirely in Desmos and get the answer. All right, let's look at the next one. question number 3 here. So this question says a lot of things. However, it's actually a very simple or basic question. It just contains a lot of words to try and trick and confuse you. So you have two similar triangles. Okay, ABC and DEF. The base of ABC, side BC, 9 times the base of the, okay, so whatever. This is x, this is 9x. Then the height of each triangle is 2 times the length of its base. So that means this would be 2x, this would be 18x, right? Just multiply the base by 2. How many times larger is the height of triangle ABC than the height of triangle DEF? Well, it's just 9 times larger, and that's it. And you can either see that from my picture, 18x is 9 times 2x, or you don't even need to figure that out. If you just look at this sentence right here, the base of the larger one is 9 times the base of the smaller. The heights are going to have the same ratio because they have the same scale factor because these are similar triangles. So every side has the same scale factor because they're all proportional. Therefore, it's just going to be 9 times as larger as well. And that's it. You don't need to do any more work. Okay, next up, problem number 4, at the top of the next page, you have a scatter plot with a bunch of points on it. You have a line of best fit. And essentially, the two things that are being graphed here are the number of seeds that were planted, basically planted seeds along the x-axis, and then germinated seeds along the y-axis. Okay, so every point will have an x-coordinate and a y-coordinate, and x-coordinate is the number of seeds that were planted, y-coordinate number of seeds that were germinated. Okay, so which of the following is the best interpretation of the slope of this line of best fit for the scatter plot? So remember, of course, slope is basically change in y over change in x. So as we read through and look at these answer choices, basically what you have to recognize is, okay, the first two are kind of written in what you might consider like reverse order. They're talking about basically the x values increasing by some number for every some increase in the y. Now, we're going to still look at the numbers to confirm that they are not correct numerically, that they don't match on the graph. But the wording of them is essentially backwards for what we would expect to describe the slope. Whereas C and D are in the kind of the proper format where it's talking about a change in x, for every given change, a change in y for every given change in x, because the planted seeds are x and the germinated seeds are y. Anyways, with all that being said, let's look at answer choice A. Number of planted seeds expected to increase for every 100 by 82 for every 100 germinated seeds. So basically, if we go up, if we start here at 0, 0, now this line, subset out from the graph, I don't think it goes exactly through the origin, but it's close enough that I'm just going to treat it as if it does. So if we increase by 100 germinated seeds, so go up here to 100, okay, is the change in the x or horizontal amount of the line equal to 82? Okay, no, it is not. You can see it's clearly over here. It's somewhere between 120 and 130. It does, the number of planted seeds, in other words, is not increasing by 82. 82 would be an increase like over here. All right, so therefore, this is wrong. All right, now let's look at answer choice B. Just clear this stuff off. All right, number of planted seeds expected to increase by 122 for every 82 germinated seeds. Okay, so now we're going up here to like, a little over 80, and when we go across here, okay, so we go up, planted increases by 82, germinated increases by 82, planted increases, does it increase by 122? No, it looks like it increases by about 100. So this is wrong. The numbers don't match. All right, now let's look at C and D. These are the ones that, basically you can kind of tell are going to be correct from the beginning just because of the formatting, the way that they're written. So C, number of germinated seeds expected to increase by 82 for every 100 planted seeds. Okay, so let's go increase the planted by 100. So we go this way by 100, and then when we go up, has this increased by 82? Well, it looks like it has. I mean, it's tough to tell because you have to zoom in on the graph or whatever, but the point is it's right around 80. The 80 line is right here, so maybe it's a little bit above it at 82. So it looks like C is going to be correct. And if we compare now D, basically we go through the exact same process, except D has it up at 122, which means that the slope of the line, would basically be going through up here, just over 120. So the line would have to be, looking something like that, okay, which obviously it isn't. So the correct answer for this problem is just going to be letter C for the slope of this line. All right, next one. Let's take a look at question number 5 here. So you have this line, linear function, and it's perpendicular to another line, another linear function, and they give you some points that this new linear function passes through. K is a constant. What's the value of K? All right, so if you want to do this by hand, what you can do is you can notice the slope of this first line is 2. Therefore, the slope of the perpendicular, which is G, is going to be negative 1/2. And that would be equal to the change in the x value, change in the y values, 5 minus k, over the change in the x values, k minus 1. So now if you go ahead and cross multiply, I'm just going to put the negative on the 1 here. So it's negative 1 times k minus 1 equals 2 times 5 minus k. Negative k plus 1, 10 minus 2k. If I add 2k to both sides, I get k on the left. Subtract 1 on both sides, I get k equals 9. So that's my answer. And that's what you could plug in. Now, of course, you could go to Desmos, and you could do this entire problem in Desmos. What you would have to do, so there's multiple ways you could do this. First of all, you could calculate this. You have to calculate the slope. So that's the first thing. I mean, you could just type the equation in like this and just solve that and get k equals 9. But even if you don't want to set up the formula for slope, or you forgot the formula for slope, what you can do is you can type the x coordinates in a list. You can type the y coordinates in a list. The reason you have to use a list and not a table is because of the k constant. If you try to do it a table, it's not going to work properly. Then you can do linear regression. We know the m is negative 1/2 because it's perpendicular, plus b. And notice when I do that now, not only does it solve for b, which we don't need or care about, but more importantly, it solves for k. The value of k is 9. Therefore, correct answer to this problem is 9. This is how you could do the entire problem in Desmos. All right, let's look at the next one. What's the radius length of a circle with this given equation? So you could, here, I will show this method by hand, even though it's a fair amount of work, and I prefer to just go to Desmos and do it in there, but I'll still show you how to get it by hand. So first thing we're going to do is you would divide everything by 2. And then I'm going to start completing the square. Notice on the right, 19 halves divided by 2 becomes 19 over 4. Okay, and that's not 14, that's 7. This should be 7 right here. So now you got 7 over 2, because that's b over 2, and you square it, and you get 49 over 4. So that's what you're adding on both the left and the right. And then here it's 8 over 2, and there's just 4, and you square that and get 16. And you add that on the left and the right. So now, what do we get over here? 49 over 4 plus 19 over 4 is 68 over 4 plus 16. 68 over 4 is just 17. So you get 17 plus 16. You get basically 33 as the number on the right side if you're going to put this circle equation into standard form. That's r squared, which means r is just equal to the square root of 33. Correct answer for this one is letter D. Now, let's see how you could do this in Desmos. So essentially what I would just do is graph out the circle, find the max and min points. Okay, so I'm going to, and then find the distance between them using the distance formula. I'm going to define this as A and this as B, just so I don't have to retype the whole things. Find the distance between A and B. That's my diameter. Divide that by 2 and I get this number, right? Okay, looking at the answer choices now, it's obviously not A and it's obviously not C. So we're down to C versus D. Okay, so at this point you could just type them in and just see, okay, B versus D. Here's B, that doesn't match, therefore it has to be D, but let's just confirm, yeah, 5.74456. So this is how you could do the whole problem in Desmos. Now at the top of the next page, problem number 7. Here you have a quadratic equation where they give you basically the form of one of the solutions. It has two constants in it, and they want to know the value of one of them. So the easiest way to solve this is actually to treat it as if it were a completing the square problem. And so what I mean by that is you start off, you add 11 to both sides, okay? And then you're going to go ahead and divide by the 81 that's in front on both sides. So that drops out. So on the right side, you've got 11 over 81. Okay. Now, inside the parentheses, this is actually a perfect square trinomial. This will factor as x plus 16 squared. And then after you do that, now you can square root both sides. Remember, of course, the plus or minus on the right side. And you get x plus 16 equals plus or minus. Now, on the top, you're going to have root 11, but on the bottom, square root of 81 is just 9. At this point, you're probably realizing that p is going to equal 9. And you actually wouldn't have to do this extra step, but if you wanted to, you could subtract 16 and then see we get our answer here of negative 16, technically plus or minus root 11 over, not p, over 9. Therefore, if you match up the constants, p is going to equal 9, k is going to equal 16. So the correct answer here is going to be letter B. Now, to solve this in Desmos, if you try to do the approach that I normally do with a quadratic equation with constants, it's actually not going to work. I think it's because the numbers are so large. So what I mean by that is if you just type in the function, and then because there's two constants, I'm going to put in both of them. So this is the, when I say both of them, I mean both solutions. So first I have the solution that's given, then I have its conjugate. Okay, and we regress each of them to 0. Okay, notice it's giving me some like fantastically large number for p. And then it's giving me some random value for k, which is not correct, which is not equal to 16. So here are the two ways you could work around this. One way is to go through the answer choices and start with, say, p equals 2. What you're looking for is then in the regression, is the RMSE, root mean squared error value right here, is this either equal to exactly 0 or is it equal to some, extremely small number? If it is, that tells you that the regression found a perfect match and that's your answer. In this case, it is not. Therefore, 2 is not going to be a correct answer. Let's try 9. Notice now the RMSE is 4.55 times 10 to the negative 13th. Not technically 0, but it's an extremely ridiculously small value. And if you check the others, you'll see they're nowhere equal to 0. Okay? And that just tells you that they're incorrect. So this is one of the workarounds if you want to solve this in Desmos. I will tell you the other workaround is to do the following. Take the function here. Okay, we have it graphed out over here. It was just kind of off to the side, right? Okay, I'm going to export these two values. Okay, these are my two roots. The smaller one is going to have the minus, root 11 over p, and technically the larger one here is going to have the plus root 11 over p. So what I'm going to do in my regression is, let's see, the positive one is first, so I'm going to do regression only with the solutions themselves, not with their y values. And then the smaller one goes second. 3, 6, 8, 5, 1. Now these are approximated, these are not exact, so, but you'll see it should still work. Okay, so if I get rid of this, yes. So notice what happens. What I'm doing here is I'm basically saying the larger of the two solutions, which is negative k plus root 11 over p, is equal to negative 15.63149. Okay, right here. Then I say the smaller of the two solutions, which is negative k minus root 11 over p, is equal to the smaller x-intercept value, negative 16.36851. It finds k perfectly at 16. It also finds p at 9.00009. Notice the RMSE is 0, so that's what we want. The reason this is not exactly 9 is because these are approximated, right? Because these are not exact values. There's more decimals after, what do I have here? 5 decimal places for each of these. There's more decimal places in it. So this is a second workaround you could use. And notice here, even if you went to round this or write it as 9.000, this extra 0.9 doesn't matter. It drops off. You still get 9 is the point for p. So those are some workarounds that you could do in Desmos for this specific problem. All right, let's talk about the next one now. Question number 8. So in this one, you have some information about a triangle, and you're trying to find an expression for its area. So basically, we don't know that this is a right triangle, so I'm not going to draw it as a right triangle. The height is represented by x. So, okay, let's say this is the height right here, and the height is 52 units longer than the base. An alternate way to word this is base is 52 units shorter than the height. Okay? That's how most people are going to think about it. That's how most people would find it easier to realize that the base is going to be x minus 52. The actual wording here, though, where it says the height is 52 units longer than the base, most people think, oh, well, the base is going to be x plus 52. But no, that's not correct. The height is the longer side, the base is the shorter side, and the difference between them is 52. So now all we're doing is we're just using the area formula. Area equals 1/2 base times height. So we got 1/2 times x minus 52 times x. 1/2 times x squared minus 52x. 1/2 x squared minus 26, because half of 52 is 26x. So now go through which answer choice is it going to be? 1/2 x squared minus 26x. It looks like it is going to be letter A. Now, an alternate approach you could take to this is using picking numbers to find values for the height and the base, and therefore calculate the area, and then compare that numerical value against all of the answer choices where you plug in the height value that you chose. So here's how that would work. I'm first going to say the height of this triangle is 100. Therefore, the base is going to be 52 units less than that, or 48. Now I would calculate the area of 1/2 base times height. That's 2400. So now we go through each answer choice, and notice what I'm plugging in is the height. Again, x is equal to the height. So I can just put the h here. Notice for answer choice A, I get 2400, which is correct. So let's just confirm the others are wrong. Okay, in B, it's the same formula, but there's no variable on the 26, so get rid of that. Doesn't match, not correct. Now technically, if I add a plus here, this is actually answer choice D, doesn't match. Now if I add the H back here for answer choice C, again notice it gives a different value. So A is the only one that returns the same value for the height, or for the area, that I get as if I calculated it using the formula. So this is just an alternate approach you could take for this problem. Next, let's look at problem number 9. Here we have a square inscribed inside a circle. So here's our circle. Here is our square. Okay, and we know that the radius of the circle, so center to corner of the square, is 21. It's also going to be 21 going this way. The perimeter of the square is a root 2. What is the value of a? So basically what's going on here is this square is divided into two 45, 45, 90 triangles, 45, 45, 90. The hypotenuse is 42. Okay, there's multiple ways you could find the side length of the square. You could technically just do, S and S and use Pythagorean theorem. And if you're going to take that approach, it's you want to go to Desmos. So we got S squared plus S squared tilde 42 squared. Now notice this gives me a decimal, but that's fine. Okay, so now I get the value of one side of the triangle. I'm just going to write it here. It's like 29.68, but well, whatever. So now to get the perimeter, I just do 4 times that. So if I go back here, I can just do 4s. Okay, I get this number. What is it? 118.793 or 739, whatever it is, doesn't matter. Yep, 793. It's right the first time. Okay, but this is equal to a root 2. If I want to solve this for a, all I have to do is divide this decimal by the square root of 2, and then that is going to be the value for a for this square. So just take this, we're going to divide it by square root 2, and there's our answer, 84. So a is equal to 84. That's what you would, type in for your answer. Second approach, of course, is if you recognize, since it's a 45, 45, 90 isosceles right triangle, to get from the hypotenuse to the legs, you would just take 42 and you would divide it by root 2. Now this you would simplify by multiplying by root 2 over itself, and you get 42 root 2 over 2, or 21 root 2. That's the exact value for the side length of the square. Then you take that, of course, and you multiply it by 4. That becomes 84 root 2. This is equal to a root 2. And now you can just see, oh, a has to be 84. Match up the two things. These basically cancel out. So whichever approach you take, correct answer to this one is going to be 84. All right, last question here, number 10 from May 2026, Digital SAT Math, official test problems, worksheet number 1. Here you have a quadratic equation and you have a linear equation, and there's exactly one real solution. It's a constant. What's the value of the constant? So this one is actually not that bad to solve by hand, because what you would do is, of course, set these two things equal to each other because they're both equal to y. And then we're going to move everything over to one side, equal to 0. I'm going to move everything over to the right, so I'm going to add 4x squared. I'm going to add 6. 0 equals 4x squared plus bx plus 4, it looks like. Just checking my notes. Now you would just use the discriminant, b squared minus 4ac, and that's going to equal 0. B here is just b, so it's still b squared. Minus 4 times 4 times 4 is equal to 0. B squared is going to equal, well, this is 64, and, well, it's b squared minus positive 64, and then you add it to the other side. So now you just, of course, square root both sides. Don't forget the plus minus, and therefore we have positive 8 and negative 8 as our possible answers. So both of these would be correct in the way that I've worded this. Sometimes in the tests it'll specify a positive constant, in which case positive 8 would be the only correct answer. But for this example, there are two of them. Okay, now let's just see how you could actually do this entire problem in Desmos. So I'm going to use the, well actually, let me just mention one thing too. I mean, it's not a lot of work to solve, like once you get the discriminant set up, it's not a lot of work to solve it. But you could also just go to Desmos and you could do something like this. Actually, yeah, we wouldn't want to do that because this is technically equal to 0, not inequality. Sorry, we just do regression. And right here, it gives us positive 8, and there's your answer. You know, or one of your answers, right? So if you wanted to do that last step in Desmos, that's fine. But for the whole problem, I would use what I call the derivative method, which is negative 4x. So first function is f of x, second function is g of x. This will find the value of a constant or constants when you want a quadratic and linear function to intersect exactly one time. I want this, okay, and then we want g of x1, g prime of x1, and there we go, we have the answer, negative 8, and also if you use this approach, you can visually see the intersection. It's right here at 1 comma negative 10. Now, there technically, like I said, is a second solution, so if I put a restriction here and make b positive, now it gives me the other correct answer, the positive 8, and notice now the intersection's on the other side over here at negative 1, negative 10, instead of positive 1, negative 10. So there's two correct answers, meaning there's two tangent lines you could draw, and this is just how you could do the entire problem in Desmos. All right, so I hope you enjoyed this video. If you did, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Also, check out the videos for part 2 once that is posted for 10 more new problems from May 2026. And also part 3, which is going to highlight 20 repeat problems that were reported to have appeared on this test that I've covered previously, you know, in previous worksheets and previous videos. So make sure you check those out. Otherwise, do check out the playlist with links to all the other videos, you know, from previous months and worksheets, the self-reported official test problems. Now up to, I think it's about over 430 total problems covered, you know, going back to May of 2024. Also, if you haven't done so, there is a spreadsheet which basically has every single problem listed, and it has the main kind of topic area and then like a subtopic, more specific topic area as well. It shows which problems are repeated from which months, meaning it shows some, like, you know, a problem was first covered in August 2024, and then I did it again in March of 2025 or whatever. So there are ways to look for problems that have been repeated multiple times. There are ways to search for specific topics. It doesn't have all the details of a problem in the kind of the notes column, like the last column, but it does have a general description of most problems. And it also has links to all the YouTube videos in it, including the alternate solution videos and the repeat problem videos as well. One last thing to mention, if you're looking to improve your knowledge of Desmos, then please check out my Ultimate Desmos Guide to Digital SAT Math. There are two versions of it now. There's the free version, which is on my YouTube channel. Currently has over 70 practice problems. Covers, you know, all the various topics from your basic core skills up through advanced topics and the various types of regression that you can use to solve constants and the various problems you find at the end of Module 2. And then there's now also a premium version that you can purchase on Udemy. The material in both of the courses is essentially the same. The main advantages to the premium version are that it's ad-free. In other words, you don't have to bother watching ads like you would on YouTube. And I've re-recorded some sections of it and basically rearranged them, especially the advanced skills, so that the common types of problems that have multiple methods are all grouped together. So in other words, all the different methods you can use to solve for a constant in a system of linear equations are all together in one video. And all the different types of methods you can use for solving to find the value of a constant for various types of quadratic problems, are all basically grouped together in one method. So it's organized a little bit better than compared to the original, free version on YouTube, where the problems and the topics that are covered in it are basically just, chronological as I, figure them out or discover them. So in either case, please check out either of those. They're loaded with tips and tricks and basically all the practice problems and skills that you need to ace the digital SAT math section using Desmos.